all fired up. Okay, our next speaker is going to talk on technology in a bag. Seed advances from Mesopotamia to St. Louis is the title, but that's okay. Carl Peterson is proud to say that he lived in the same house his entire life, and he's never had a job. Which means he grew up and still lives on the home place that his grandfather purchased in 1918, and that as an entrepreneur and small business owner, he has never had to go through an employment interview. Carl thrives on identifying and solving problems. His professional credentials include a BS in Ag Production from Iowa State, an MS in Ag Economy from Purdue, an MBA from Indiana. Looks like he's been a student a lot. Oh, and is a CCA and is CCA accredited. Carl reads voraciously, and most weekends he can be found playing the piano and singing in his church worship team, singing on his church worship team. And as a master of trivia, he always seems to have a quirky comeback. Carl?
Okay. So I had to ask for a different microphone because I just can't stand behind the podium and talk like that. It just doesn't work for me. I could absolutely explode. Okay, so just to address, we're talking about a land bubble. So in 1918, my grandfather bought the home farm, which was the worst time in 100 years to buy land. And of course, he died in 1959. I was born in 1959, so he was not around to tell me in 1981, don't buy that overpriced land. So we're talking about the $10,000 an acre land. Okay, so they gave me the topic, seed advances from Mesopotamia to St. Louis, and I thought, cool, that sounds like a lot of fun. And of course, there is no history of seed, because what there is a history of trying to feed the people that we have in the world, and seed is part of that, right? So I'm thinking, this is going to be just great. And then they said, you have 20 minutes. So I'm going to have to leave things out. If I talk fast, yeah, it's kind of natural, but, I'm going to have to do that. Okay, so Cal showed this earlier, world population historical. We've got good numbers after about 1700. This is a lot of conjecture, but the graph is accurate. We've got a huge increase in production starting around 1917. Starting about 1700s. What's interesting about that is if you graph wheat yields alongside of that, how well that parallels. Now I'm going to confess I cheated a little bit in that this green line are U.S. wheat yields. So if you did wheat yields broadly, the increase is less, but the point remains. And from here back, you know what? We're just guessing. But this is the best information that Mr. Google had for me about what wheat yielded, in BC 2000, right? Okay, so in 1798, Thomas Malthus said, population is increasing faster than food production. We're all going to die. Life is going to be brutish and short, and it's awful. Then we had the Green Revolution, 1960s, which was already touched on. Phenomenal things. We had enough food to feed people. Paul Ehrlich in 1968 published the population bomb. My gosh, we're all going to die. Mass starvation by the 80s. By the 80s, we had huge grain surpluses that tanked the ag economy. Talk about something in the history of North Dakota, how the farm country and small towns just emptied out in the 80s because of the huge grain surpluses. But there's a problem, and that is, although this wheat yield thing parallels pretty well, up to about this point, we're increasing food production, not only by increasing yields, but also increasing the land in production. And we've come almost to the end of the available land to be brought into production. Yes, there's some more land in South America, actually a lot of land, but it's on rainforest, and so we're hoping not to do that. Okay, so there's really three primary steps to how did we get to where we are now in seed production. Domestication and land races, single line selections, varieties, conventional breeding. Okay? We're going to talk about those individually. For many, or some of the other crops, there's two others. One is hybridization, which works for some crops, not for others. The other is genetic modification, which has been applied to some crops, but not yet applied to others. So, the formation of land races, essentially what happened is, wild plants are set up to disperse their seeds into the environment so they can get scattered around. There were some defective ones in various crops that held on to their seeds. Those were selected, in a very loose sense, in order to provide something that they could domestically grow. And then they kept the best ones. Over a long period of time, change occurs. Genetics will vary geographically. So what happens if you have a landrace of wheat that's raised in a southern area and growers start to move north, the genetics in that will shift. Just because those that did poorly in the south will become less dominant, those that work well in the north become more dominant. So that's essentially how that works. It's pretty simple. Adaptation occurs within varied populations, which gives you separation of the genetics over thousands of years. Variation does provide some environmental protection. We talked a little bit about the corn, the southern blight that they had in the 70s. Because there's great genetic diversity in the land races, there was some protection for that. Sometime around the mid-1800s, they started doing single-line selections in which they picked the best variety or the best plant out of those land races and started purifying them into a pure line, increased seed production from that plant. So that kept the line separate and more or less pure. That had higher potential yields, but was more genetically narrow. So then conventional breeding, actively crossing two distinctive lines to create something new. And then selecting from those offspring to create new varieties. The land-grant universities were pioneers in this. That was a huge thing that came about because of the land-grant universities. Most historical yield increases, I'm going to show some historical yield tables, and most of those, in most cases, are from this breeding. The question is, have we captured most of the potential? Because if you look at those increases, they're starting to slow down a little bit from conventional breeding. Okay, hybridization, producing seed in quantity by crossing two distinct lines. Essentially, they make commercial quantity seeds out of two different varieties. Very successful in some crops, corn, sunflower, and canola. Very difficult in others. And one of the biggest reasons it's so difficult in wheat and soybeans is that the male parts of the flower and the female parts of the flower are almost in the same exact spot. They're very close to each other, whereas in corn, the tassel on the top provides the pollen, and the ear is down the way. So they're spatially separated, so it's easier to breed. It's much easier to hybridize. Results can be dramatic. On this side here, we've got, these are the fuzziest. It's a little fuzzy, but this is a female parent, this is a male parent, and this is the ear produced by the offspring of hybridization. It's hard to see, but these little short ones are the parents, and the one in the middle is the hybrid. I think my kids think something similar to that happened between my wife and I and them, because they are clearly superior. Genetically, actually, you said in their minds, actually, they're not here. Objectively, they are. Using advanced biological techniques to create genetic changes, typically cross-species. For example, the Roundup-Ready gene that allows a soybean to be resistant to Roundup came from a soil bacteria. Highly regulated, input traits are dominant now, herbicide resistance, insect resistance, so on and so forth. But output traits have huge potential. How about corn with higher protein? Or soybeans with omega-3 fats? Those kinds of things are coming. And just to be clear, no health or safety issues have ever been documented. A lot of claims, no documentation. Okay, so this is wheat yields. This is a graph I showed you before. This is from 10,000 years ago up into about this time frame was the land races. Here we got into single plant selection, and here's conventional breeding. So that shows you what science has done for food production. Now, coming up after me will be Dr. Franson. He's a fertility guy. He's going to tell you this all happened because of fertilizer. Don't believe it. Actually, it's a combination. You couldn't do it without herbicides. You couldn't do it without chemistry. Certainly couldn't do it without fertilizer. Okay, so wheat originated in Mesopotamia. Wheat can be grown everywhere. Most complex genetic makeup of grains. This is important. It has 6 sets of chromosomes, which basically most species have 1. So it makes it much more difficult to breed, to hybridize, and it makes it more difficult to do genetic modification. Historically, this is the most important grain in the West, and it was obviously crucial to the settlement of North Dakota. When we look back at this graph, when North Dakota was first settled, there were some reports of yields up in the 30s and 40s on the fresh broken prairies. So that was huge. Okay, there's soybean yield. Not as dramatic. I'm only starting in 1924 because soybeans have not been around as long. Soybean particularly, they originated in China, brought to the U.S. as a forage crop in the 1800s. They're very difficult to hybridize. They were not significant in North Dakota until the 1960s. Currently, North Dakota's second most dominant crop. 95% are GMO, which is Roundup Ready. It's inarguable that that was a contributing factor to North Dakota's increased soybean production. And they're really a wonder plant. In the 1920s, there's a picture of Henry Ford next to a car where the panels are made out of plastics that were derived from soybeans, and he is wearing a suit that was made out of soybeans to a large degree. He was a big booster of soybeans, so you can make almost anything with soybeans you can make with, that said like 12 minutes before, now it says 10.
Yeah, that happens.
So how much do I have? 10. Okay, good.
Yeah.
Oh, it's counting down. Okay, got it. Okay. Okay, so here's corn yield. Again, corn came from Mexico and it was domesticated out here. I don't have that on there. So here's the land races and you've got the time of breeding. But here is hybridization and breeding. Corn was originally teosinte, which looked like this plant. Many different seed pods. The seeds were out on the end. And in corn you have the ear and then you have the tassel on the top. And there are about 5 genes difference between teosinte and corn. So that much difference with 5 genes, that's kind of amazing to me. I'm not a scientist, I'm just a farm kid, but that's still. Okay, corn particulars, 5 genes difference with teosinte has shown the most yield growth of all the grains. It's easy to breed and hybridize because of the spatial separation of the male and female parts. 80% plus genetically modified in the United States. Herbicide resistance, insect resistance. People have been trying since day one to show how bad this stuff is, and they have not yet succeeded. Herbicide resistance, insect resistance. Okay, there's lots of new GM stuff in the pipeline. I talk to a lot of farmer meetings and talk about what's coming. I don't have those slides in here, but higher nitrogen utilization. When you look at the spatial spread of corn throughout North Dakota, that's going to accelerate when we get water utilization genes incorporated into the genome. Again, output traits, a lot of different things that are going to help that. North Dakota acreage is increasing rapidly, and I expect it to continue to increase. Okay, so all this breeding, how does this happen? This is the traditional model. Public breeding model. You have public support, funding land-grant universities, which breed different crops and put out new varieties, and that value flows out to farmers in the industry. I would argue, from an economic standpoint, that the unsustainability of that particular model is that the people who are paying for the support are not the people that are directly reaping the benefits. And so I would say that's probably why we have increasing difficulties as our state urbanizes. Believe it or not, North Dakota is considered an urban state. It's harder to generate that support for those kind of programs. There's also the private breeder model with Save Seed. And this is what happened prior to GM with soybeans, and this is what the model that still exists in some degree for wheat today, and that is the private breeding programs create new varieties, which the benefits of which flow to farmers and industry, and there's some trickle of benefits back towards the breeding programs in order to increase those breeding, keep those things going. Okay, the private breeding model with no Save Seed, the private breeding produce new varieties, the value flows to farmers and industry, and lots of dollars flow back to the private breeding programs, generating lots of dollars for research. So we take a little bit of a look at the result of that. So the blue line is wheat yields. Now we showed a dramatic increase, but when you put it on scale, it doesn't look quite as impressive. The green line is soybean yields. And then the orange line is corn yields. So you can see that up until the 30s, yes, corn yielded higher, maybe as much as twice as much higher, but the spread wasn't that much. Since that time, however, primarily because of hybridization, and I would also argue because of the private breeding model that has predominated since the 40s and 50s and 60s, and even more so today, has increased that gap. So when we look at why is there more North corn coming into North Dakota, because the productivity gap is widening. That was basically, I think, the answer to your question. So one of the things that you hear a lot from food advocates and so on and so forth is that we have a low quality food supply in North Dakota, and corn is what's making us fat. So as a fat person, I can tell you that it's actually the donuts that are making me fat. But nonetheless, if you look at this economically and scientifically, we're going to be way better off and way ahead if we're able to incorporate better nutrition traits into a grain that has this kind of productivity than if we are going to try and push down to say, instead of 150 bushels, we need you to produce something that produces 50 bushels. And so that's the key there. Okay, so not to step on what you were talking about, but I think it's really important. This is acres of North Dakota, not by county, but by state. And you can see here that since 1944, with 3 exceptions, we've been about 10 million acres of wheat. Okay? There's this gap in the 50s and the 60s where it dipped, and this gap here. And I would argue that that's, as much as anything, the result of government set-aside programs where they said, we're going to pay you not to produce, we're going to create soil banks, and so on and so forth. However, this decrease that we see coming here is for other reasons, and that's economics. I showed you that spread of the productivity gains between wheat and corn, and that's going to continue to grow. Historically, barley was the second largest crop in North Dakota. You can see barley has gotten down to the very thin sliver. Flaxseed was once the third largest crop in North Dakota. Hard to find a flax field anymore. Corn always was a little corn throughout North Dakota, but you can see here as that productivity gap finally started to catch up with our economics, that started to increase. Sunflower had a boom in the 70s, but is also again becoming a minor crop. Soybeans, huge. Incidentally, my wife and I were lucky enough to start a corn and soybean seed company right about here. I wish I could say that was because we were smart, but I'm going to have to admit it's because we were lucky. But anyway, and then some minor crops. Peas, sugar beets, canola, beans, and if you separate the dry beans into the different kinds, there's many, many different kinds. Sunflower, flaxseed, barley, etc., etc. One of the things I would like to point out, you see this little purple line here, is sugar beets. Sugar beets are a huge crop importance in North Dakota, especially in the eastern part of the state. But in terms of acreage, there's just not that many. Sometimes the tail wags a dog just a little bit with that deal. Okay, so North Dakota, these are the 3 primary crops. That's one of the reasons that I focused most of my talk on those, because they are the 3 primary crops in North Dakota, but also because they are 3 of the 4 primary food and feed crops in the world, the other one being rice, which to my knowledge has never successfully been grown in North Dakota. So again, apparently I talked fast enough that I'm going to come in actually under time. This is that graph of world population that I showed earlier. And so far, we have been able, as farmers, to create enough food to feed all of the 7 billion people that we have in the world. There are a lot of people who are hungry. There are a lot of people that are starving, but it isn't because there's enough food. Those are economic and political problems. But I also showed that we've pretty much taken all the arable land that we really can sustainably. And this is what world population is supposed to do. So we're going to have, we've got quite a challenge to increase that productivity in a sustainable way so that we can feed all of those people. And as long as I have one more minute, I want to talk just a little bit briefly about something that Mr. Petrie was talking about, and that was the idea of cheap food. Because we have cheap food in this country. I'm not sure if the price of donuts doubled, if I would eat less of them and get less fat. But when you think about the world food situation, as a farmer in North Dakota, I'm producing food not really so much for people in Bismarck or Fargo or Minneapolis, but people around the world. Much of our agriculture production is exported. And so when we think about our food systems and how we're going to regulate and put those together, we have to think about people who don't spend 10% of their income on food. We have to think about the people who spend 80% of their income on food. The rich people are going to get what they want in the food supply before the poor people get what they need. And when I talk about the rich people, I'm talking about everyone in this room. If you look across the whole spectrum of income levels across the world, there aren't many poor people. I would argue there are hardly any in the United States. But across the world, there are a lot of people who are trying to live on $2 a day. And so the cheap food issue looks completely different to that person than it does to somebody like me. So I kind of had a little time at the end, so I kind of went off on a tangent there. But anyway, so I'm done now.
Okay. Anybody have a question? Lots. I'll get you next time.
What percentage of our fruit products are exported?
30.
So I'm hearing 30 from down here. So and I have no reason to dispute that, but it varies greatly by crop, okay? So I believe we're currently net importers of fruits and vegetables, certainly of certain fruits. Soybeans, at one time, 2 out of every 3 rows of soybeans was exported. It's probably less than that now. Corn has actually decreased in proportion as ethanol has increased. Wheat, I'm not sure of, but it varies significantly across. The commodity crops have higher levels of exportation than do the direct food crops.
One of the primary uses now for corn is high fructose corn syrup. Are you saying that this can be genetically modified to provide health benefits versus weight gain?
Okay, so your question carries with it an assumption, and that assumption is that high fructose corn syrup in some way is more fattening than our good old American beet sugar.
I'm saying it's consumed more.
Okay, so consume more. Well, if you eat sugar, you get fat. I'm living testimony to that. And so typically, as a business person, we'd like to produce what people want to buy, right? So, there are good artificial sweeteners, but if people want to buy Mountain Dew, and if the bottling company decides they're going to use high fructose corn syrup as opposed to sugar, that doesn't really, I don't have a lot to say about that.
But my question is, can you genetically modify corn so there are health benefits built into it? You're talking about the evolution.
So that's a much broader question, yes. Can you genetically modify corn so there are health benefits?
Versus weight gain.
Well, but you see, here's the problem. The weight gain is caused from eating too much of something. And so unless you put some kind of an appetite suppressor into the corn, the answer is no, I can't. You can't produce food. Well, you can actually. You know, if all we had to eat was broccoli, I would be thinner. But the problem is, of course, if we produce foods that people want to eat, some of us are going to eat too much of them, and we're going to get fat. One of the things that is high demand by the consumer are sweet things, and so the industry has developed high fructose corn syrup, which is one of many products that you can make out of corn. I mean, you can make a drinking cup out of corn, or you can make beef out of corn, or you can make high fructose corn syrup. I'm certain you could make something worse than that if you tried. But you know, that's really that's a pull issue, not a push issue. We can't push those things through the system, we can only pull them. Now, as far as health benefits, absolutely. There are many things that could be incorporated into corn and will be incorporated into corn that could provide health benefits. Some blood pressure reducing compound of some kind could very easily be put into that. Now, you've got some regulatory issues with that. You've got some economic issues with that. A few years ago, so I read a lot of farm magazines. A few years ago, all the farm magazines were talking about pharmaceuticals spelled with an F, right? We're all going to be producing corn that has vaccines and so on incorporated into the genetics of those products. That can be done, has been done, and is being done. The reality of that is, though, if you produce, some kind of a corn hybrid that's got like a statin medication, I know there's at least one doctor in the room, so I got to be careful. I don't know anything about this stuff, but something that has that kind of a drug thing in it, you don't need 9 billion acres of that, or 9 million acres of that, or 10 million, or 70 million. You need 2 acres. So that's not really, those kind of things typically aren't a factor in the ag economy. That makes sense.
Other questions?
So your business is to sell corn seed to producers?
Pardon me?
Your business is to sell corn seed to producers?
Corn and soybean seed, correct.
So do you sell what kind of seed for ethanol production and another kind for cattle production?
Nope. So the question is, do we produce a different kind of seed for ethanol and a different kind for... No. Corn is pretty much an undifferentiated product. Now there is in the marketplace right now a corn hybrid marketed by Syngenta, which contains an enzyme which increases the production of ethanol in an ethanol plant. But there again, that's not something that the ethanol plant doesn't need 100% of their corn to be that hybrid. They need some smaller percentage, 8 or 10, something like that. Aside from that, it's pretty much, corn is pretty much an undifferentiated product. I mean, there are non-GM for things, and there's white, if you go buy white corn chips, they're made with white corn. Those are kind of specialty things, and of course, there's sweet corn, but that's a whole other can of worms. Hopefully there's nobody in North Dakota still that thinks sweet corn and field corn are the same thing. But you do run into that a lot. People drive through Iowa and they go, I can't believe who's eating all that sweet corn.
Any other questions?
It was on the front page of the forum, you had a picture of sweet corn talking about federal subsidies.
Sure.
Yeah, I thought I'd throw up. Yeah.
In Fargo.
In Fargo. Front page.
So I'm 20 minutes from Fargo, and I can attest that the understanding of agriculture is not that high.
The question came up earlier about the declining amount of federal and state support for agricultural research. And you've been around this business a long time, and so have I. And seen them, where the private research, huge DuPont's, Pioneers, Syngentas, Novartis, you name it, and they keep growing, are really filling in a lot of the basic research. What are the needs that you see? Where do you think the priorities for public research ought to be?
So that's sort of a loaded question, especially when one of our great people from NDSU is right here. But what private industry tends to do is focus on research that makes money for the company, right? And so, a lot of times people frame that up in, they're evil, they're just doing, but really what they're doing, the way they make money is they sell things to people that want them. So they have to produce something that people want in order to sell it, because, they freely give them their money and then they use that money to further the research. Okay, so the problem with that model is the very basic kinds of things that higher up the food chain, you might say. So I'll give you an example. So Monsanto was the company that first successfully, commercially created a transgene crop, right? But most of the basic research that they used to do that was done at universities. So, there's a level of research which is sort of beyond what is obviously commercially viable. And I think we need that public sector, not just in agriculture. I mean, this is something that I think applies broadly across society as a whole. Government funding for that kind of basic research, if that makes sense. That was soft enough answer to not get me in trouble with anybody.